Hello dear students, I am Ronak Kumar, your physics faculty at Aakash, and a very warm welcome into this session in which we will be discussing the problems based on the AIATS plus phase 2 mock test 1 that was conducted on 19th of January 2025. Now I will be taking the last session for the day and I will be discussing the problems based on the chapter of Ray Optics and Optical Instrument, right? Ray Optics and Optical Instrument and Magnetism and Matter, Waves, Oscillation, Wave Optics and Semiconductor. All the chapters, they are the difficult ones and you face a lot of difficulty in dealing with the problems of, problems of these chapters. Now, let me move through the first problem, and this is the first problem, and it was the problem 11 in the original paper. It says that plot of deviation, that is shown by delta, versus angle of incidence, that is shown by I, for two equilateral prisms. Now, the keyword is equilateral. With the help of this keyword equilateral, I can get the information about the prism angle. And since we are talking about the prism angle, the prism is equilateral. That means the prism angle will be 60 degree, right? So I have derived this much information from only this part of the problem. Now let's move forward. Equilateral prism P and Q of different refractive indices are given in the diagram. So you have been shown the variation of deviation with angle of incidence for two different equilateral prisms, right? And you need to compare their refractive indices, that which one is having a greater refractive index. Let me show you the option. Option says that mu p is greater than mu q, mu p is less than mu q, or mu p is equal to mu q. These are three options, and fourth one is data insufficient. That means that this data is not sufficient to get to any conclusion in this problem, right? So let's start the discussion. So this is the graph right in front of you, right? And if I plot this, see this. This is the angle of incidence. Let me name this as IP, right? Sorry, IQ. This one is IQ. So let me name this as IQ only. So this one is IQ and this one is del Q. This one is the angle of incidence for the minimum deviation. And I can write this as IP, and this one becomes mu p. Sorry, not mu p, it will be del p. So it will be del p, right? So I hope you are clear till this step. Now let me apply if I draw the prism right in front of you, this is the prism, right? And this angle or the prism angle, this is equal to 60 degrees, right? Now, if a ray is incident like this, this will be the normal, and suppose the ray goes like this. So this will be angle of incidence and this will become your angle of refraction, R1. Let me take this as R1, right? I'm dealing with the case of minimum deviation. In that case, for the case of minimum deviation, I can write that R1, it would be equal to A by 2. And what is A? A is 60 degrees. So 60 by 2, it is equal to 30 degrees, right? R1 is A by 2, and it will be same for both the prism. Either you say it P or Q. Now let me apply the Snell's law on this interface. So I'll write that 1 into sine of I. 1 into sine of I, it should be equal to, let me take this, the refractive index of this prism as mu. So it will be equal to mu into sine R1, right? And let me simplify this. I can write that sine of I, it will be equal to mu, right? Mu into sine of R1. R1 is 30 degree, sine 30 is 1 by 2. So mu into 1 by 2. So I can write that sine I is coming out to be equal to mu by 2. What can we conclude from this part? What can we conclude from this part? Sine I is equal to mu by 2. We can conclude that more will be the refractive index. The more is the refractive index, more will be the angle of incidence for the minimum deviation, right? So more is the refractive index. जितना ज़्यादा refractive index होगा, उतना ज़्यादा angle of incidence होगा for the minimum deviation. Now see that the angle of incidence for the minimum deviation is more for prism P which means that from this logic I can conclude that refractive index of P must be greater than refractive index of prism Q. So mu P should be greater than mu Q should be the correct answer to this problem, which means that the correct answer mu P should be greater than mu Q. It should be correct option. Mu P is less than mu Q, it is obviously wrong. This one is also wrong. And let's talk about the fourth option, which says that data is insufficient. Obviously data is sufficient to get to any conclusion. So I hope this problem was clear to you. Okay, this problem is clear to you and the correct answer is 1, and this method is clear to you, right? Okay. Okay, good afternoon everyone. Okay, now let's move forward to, okay, this was the problem, and let's move forward to the next problem. Okay, so this is the next problem. It was problem 26 in the original paper. It says that a small red mark, again the problem based on ray optics, a small red mark on a tabletop is viewed from a distance of 20 centimeter. It appears to be raised from the same point when viewed through a 12 centimeter thick glass slab of a refractive index 1.5 held parallel to the table. The distance through which it appears to be raised is, we need to find the distance through which it appears to be raised. Let me solve it for you. So this is my glass slab, right? Let us focus on the concept. First, we'll build the concept that is needed to solve such kind of problems. Please ignore my drawing. This is your glass slab. Let the refractive index be mu. I'm writing somewhat over here. The refractive index, let it be mu. And let the thickness of the glass slab be T, right? The point is supposed to be here. One of the point is here, right? And suppose that it lies at a distance of D from the glass slab. And the observer is over here. The person is observing this point from here. So let us go through the ray diagram or the basics to understand the concept. So I can draw one of the ray that will appear, that will go perpendicular. So obviously it is not going to undergo any deviation, right? Let me try another ray. I'll put another ray like this. Had there been no change in the medium, this ray would want to go like this, right? But there is a change in medium, so the path of the ray will not be like this. So from here to here, the ray goes from rarer to denser medium, so it should bend towards the normal. So it will move something like this. And from here, it is going from denser to rarer, so it will move away from the normal. It will go, let me draw it again. So it will go something like this. So if I trace it back, so if this is the original object O, this observer will see that this object will appear to be raised at this point O prime, right? This point O prime, तो observer को क्या लगेगा कि object O पे नहीं O prime पे है. This is the amount of displacement, or this is the distance through which the object has been displaced due to this glass slab, right? And since this displacement or this moving of object is along the normal, so it is also called the normal shift. इस चीज को आप normal shift भी बोलते हैं, because this takes place along the normal direction, right? So O, this object seems to be at O prime. Now we need to calculate this distance. It's a basic calculation. I'll get you the result. So this part, this shifting, it is equal to T times of 1 minus 1 by mu. T times 1 minus 1 by mu. T is the thickness of the glass slab and mu is the refractive index of the glass slab. Now, so according to the problem, here is your glass slab, here is your red mark, and they are asking you that if an observer is over here, which is a distance of 50 centimeter, so up till which point this object will appear to be raised. So let us assume that it appears to be raised over here. So this distance, it should be equal to T into 1 minus 1 by mu, right? So T into 1 minus 1 by mu, let me calculate this for you. What is the thickness of the glass slab? It is 12 centimeter. So 12 into 1 minus 1 by mu. What is mu? 1.5. So 1 minus 1 upon 3 by 2, that is 2 by 3. So let me rub this. I'll write it directly. 1 minus 2 by 3 3, or it should be equal to, let me solve this over here, 12 into 1 by 3, that is equal to 4 centimeter. So it will appear to be raised by 4 centimeter, and according to the calculation, the correct answer should be option 3, that is 4 centimeter. Right? So this one is wrong, this one is wrong, and this one is also wrong. Correct answer should be option 3, that is 4 centimeter. I hope this concept was clear. Now, even if you understood this concept, let me give you some more numericals to build your concept or to strengthen your concept. Suppose that this is my glass slab, right? This is my glass slab, and this is the normal. Converging rays are coming like this, right? Now, if the glass slab, okay, someone is saying ये मेरा favorite problem है sir. Oh, thank you. Okay, if the glass slab, अगर glass slab यहाँ पे नहीं होता, if the glass slab has not been here, then these rays would tend to converge at this point. At this point, let me name this as P. But, let me take the thickness of the glass slab as T and refractive index as mu. But since the glass slab is placed, these rays will tend to converge at this point, P prime, right? Now you tell me what should be the distance equal to PPP. This was the initial convergence point if the glass slab was not there, and this is the convergence point due to the introduction of the glass slab. Now what should be this distance, PP prime? So if you calculate this again will come out to be equal to T into 1 minus 1 by mu. Got it? So that is how you can utilize this concept of shifting of object if we present a glass slab. Now, if you understood the concept, attempt this problem. This is the additional problem that we are giving to you to further strengthen your concept. Have a look at the problem. It says that a slab of glass of thickness 6 centimeter and refractive index 1.5 is placed in front of a concave mirror. So you have a concave mirror right here. A glass slab is placed like this. Okay, in the faces of the slab being perpendicular to the principal axis. So the faces of the slab are perpendicular to the principal axis of the mirror. If the radius of curvature of mirror is 40 centimeter and the reflected image coincides, the reflected image, it coincides with the object, then the distance of object from the mirror is what we are required to find. Now, anyone, please put the answer in the comment box. If you understood the concept, this problem is easy. And let me give you a hint. If you are dealing with a concave mirror, if you put the object, let me assume that the focus of this concave mirror is F. If you put the object as 2F, in that case, both object and image will coincide. They will be formed at same place. Object and image will coincide. Now this is the hint part. If you got the hint, please solve this, that what should be the distance of object from the mirror so that it coincides, and the condition of coinciding for the case of concave mirror is that the object should be placed at 2F. Anyone can put the answer in the comment box. Okay, let me solve this for you. Here is your glass slab, here is your object. Now what glass slab does, this object will shift along the normal towards the glass slab. So if this is the original object, the object will shift somewhat here. Let it be O prime, right? And this shifting will be equal to T times of 1 minus 1 by mu. This shifting will be again equal to T times 1 minus 1 by mu. Let me assume that the distance of object from the mirror is alpha, right? So what is the value of this shifting? T into 1 minus 1 by mu. So it will be equal to 6 into 1 minus, and the refractive index is 1.5. So 1 by 1.5, it becomes 2 by 3. So it becomes 6 into 1 by 3, that is 2 centimeter. Shift. Okay, let me solve this over here. T into 1 minus 1 by mu is what I'm trying to calculate. So it is 6 into 1 minus 1 upon 3 by 2, that is equal to 6 into 1 minus 2 by 3, it becomes 6 into 1 by 3, that is equal to 2 centimeter. So what happens is that this object, it gets shifted by 2 centimeter, right? So if this distance is alpha, then this distance will be equal to alpha minus 2. This distance will be equal to alpha minus 2. And if the object and the image are coinciding with each other, using this concept, I can write that alpha minus 2, it should be equal to, the radius of curvature is 40, 2f is equal to 40, so alpha minus 2 should be equal to 40. This implies alpha should be equal to 42 centimeters. Alpha should be equal to 42 centimeter. Yes, very well. A lot of students have put the correct answer as 42. So yes, the correct answer should be 42 centimeter, and that's how you approach such kind of problems. So after dealing with, a little bit of difficult problem from the NEET point of view, so I hope that this concept was clear to you, right? Now let's move forward to another problem, and there you go. So this is the problem right in front of you. Let me go through the problem. It says that two thin lenses of powers P1 and P2. Two thin lenses of power P1 and P2 are in contact and coaxial, placed along the same axis. The focal length of the combination is, so you need to find the focal length of the, okay, sir also solve a question with convex lens instead of a glass slab. Yes, we'll solve this, but let us first go through the different problems that we have kept in the discussion, so it would be more fruitful for you. So two lenses of power P1 and P2 are in contact and coaxial. The focal length of the combination is what we are required to find. So we need to find the focal length of the combination. See, if you have n number of lenses, and let me assume that, okay, electricity is commenting option 1, okay. If there are n number of lenses with you, and if the equivalent focal length, equivalent power is P, then it can be termed as, this can be written as the sum of individual power of the lenses, P1 plus P2 plus P3 and so on, whatever number of lenses you have, right? Also, if this is the equivalent power, so I can write that 1 by F equivalent, it should also be equal to P1 plus P2 plus P3 and so on, right? For our case, we have two thin lenses, so I can write that P, it should be equal to P1 plus P2, right? P should be equal to P1 plus P2, and P should be also be equal to 1 over F. P is equal to P1 plus P2, and P is also equal to 1 over F. So in that case, I can write that 1 over F, it should be equal to P1 plus P2. What do we need to find? We need to find the focal length of the combination. This is the focal length of the combination, F. So F, little bit of rearrangement, F can be written as 1 over P1 plus P2. Little bit of rearrangement and focal length will be given as 1 over P1 plus P2, right? Simple problem, nothing fancy. Just a little bit of rearrangement of terms and you are good to go with the answer. So P is coming out to be equal to 1 over P1 plus P2. And this one is wrong. This one is also wrong. This one is also wrong. This seems to be the correct answer, option 4. Okay, someone was commenting option 1. No, option 1 is a wrong answer. Option 4. Option 4 is the correct answer, 1 over P1 plus P2. Now, see, since we are talking about the combination of thin lenses in contact, I just wrote that 1 over F, it is equal to P1 plus P2 plus P3 and so on, right? This equation can also be modified as 1 over F. In place of P1, I can write 1 over F1 plus 1 over F2 plus 1 over F3 and so on, right? Okay, so these are the simple concepts that you need to keep in mind if you are dealing with the combination of thin lenses in contact, right? Now, if you understood the concept, solve this problem. We have a convex lens we have a combination like this, right? The radius of curvature of both these is R1. The refractive index of this one is mu1, this one is mu2, and this one is mu3. And over here and over here, again, this is also equal to R1. We need to find the focal length of the combination. We need to find the focal length, equivalent focal length of the combination. F equivalent is what we are required to find. If you are able to find the F equivalent, so equivalent power is also easy to calculate. So P equivalent will be equal to 1 over F equivalent. So what should be the focal length of this combination? Good afternoon. Okay. Let me tell you how to approach such kind of problems. So first I will write the focal length for this part. This is a convex lens. The radius of curvature is given. I'll use this equation 1 over F to be equal to mu minus 1 into 1 over R1 minus 1 over R2. Got it? So 1 over, let me take the focal length as F1. So 1 over F1, it will be equal to mu1 minus 1. Now this will be equal to 1 over R1, and in place of R2 minus of 1 minus 1 by R1. So this part becomes 1 over F1, it becomes mu1 minus 1 into 2 by R1. Right? I hope this part is clear to you. Let's talk about the second part. Second part is something like this. The refractive index is mu2. This part is R1 and this part is R2. How to write the focal length of this part? Again the same equation, lens maker equation, 1 over F2. I am assuming the focal length to be F2. It will be equal to mu2 minus 1 into. Now this part will be negative, so minus 1 by R1, and this part, this R2 will be positive, so minus positive of R2. So the focal length becomes 1 over F2, it becomes, let me take this minus as common, so it becomes minus of mu2 minus 1, 1 over R1 plus 1 over R2. Got it? This type of question was in NEET 2023, okay? And what about this part? This part is also similar to this part, so I'll write it directly. I'll write 1 over F3 to be equal to mu3 minus 1 into 2 by R2. 2 by R1 only. Okay, this one was R1. Okay. 2 by R1. So this one was also R1. So it becomes, this one is also R1. So, okay. So I hope you are clear till this step. And the equivalent focal length, F equivalent, it can be written as, I'll write it over here. 1 over F equivalent, it will be equal to 1 over F1 plus 1 over F2 plus 1 over F3. That's how you deal with such kind of problems. I hope this problem was clear to you, right? Okay, if this problem was clear to you, let's move forward and let's have a look at this problem. Problem is 41 in the original paper. It says that for the Zener diode network, find PZ. PZ, what is PZ? PZ is the power dissipated across Zener diode. You need to calculate the power dissipated across Zener diode. Now, what is the concept involved over here? The concept involved over here is that Zener diode will act as voltage stabilizer. Voltage stabilizer. Zener diode is going to act as voltage stabilizer, right? What is the meaning of voltage stabilizer? The meaning of voltage stabilizer is that it is going to maintain constant voltage across its end, right? Across the end, it will maintain constant voltage. So across this point A and across this point B, there will be a voltage drop of 10 volt. See, across this point A and point B, there will be a constant voltage drop of 10 volt, right? And you need to find the power dissipated across Zener diode. So PZ will be equal to VZ, voltage across Zener diode, into the current IZ. Pz will be equal to Vz into Iz. Now, Vz, we all know that since it is acting as a voltage stabilizer, Vz will be equal to 10 volt. What do we need to find? We need to find Iz. Iz is what we are required to find. Let's try our luck to find Iz. See, if there is a 10 volt drop over here, this means that the voltage drop across this CD, it will also be equal to 10 volt. Voltage drop across CD will also be equal to 10 volt, and the remaining voltage, total voltage 16 volt, 10 volt is dropped across the Zener diode. So across this point PA, the voltage drop will be equal to 6 volt. This is the basic setup of the problem. That's how you approach such kind of problem. So the voltage drop across PA is 6 volt, AB is 10 volt, and CD is also 10 volt. Now, this problem is reduced to simple problem now. I need to find Iz. So to find Iz, let me first find the current through the load resistance. Anyone, can you tell me the current through the load resistance? 3 kilo ohm. Tell me the current through the 3 kilo ohm resistor. I'll calculate it further. So I'll use that V is equal to IR. So from here I can write that 10 should be equal to, let me take this current as I1. So 10 should be equal to I1 into 3 kilo ohm. So 3 into 10 raised to the power 3. So if I solve this, I1 is coming out to be equal to 3 milliampere. Sorry, not 3 milliampere. Not 3 milliampere. I1 is coming out to be equal to 10 by 3 milliampere. I hope this part is clear to you. I1 is coming out to be equal to, okay, 10 by 3 milliampere. Yes, I1 is coming out to be equal to 10 by 3 milliampere. What about the current through 1 kilo ohm resistance? Find the current through the 1 kilo ohm resistance. Let me find it for you. So voltage drop across this one is 6. Current, let me take the current as I. So I into the resistance, it is equal to 1 into 10 raised to the power 3. This implies current through here, it should be equal to 6 milliampere. So if this current is I, this current is I1, this current will be equal to I minus I1. The current through the Zener diode is equal to I minus I1. So it will be equal to I minus I1. I is 6 minus 10 by 3. 3, 6, 18 minus 10. 8 by 3 milliampere is the current through the Zener diode. We got the current, but still the problem is not over. We need to find PZ, power cross Zener diode. It will be equal to VZ into IZ. What is VZ? VZ is 8 by 3. What is IZ? IZ, it's not, VZ is not 8 by 3, sorry. VZ is 10, IZ is 8 by 3. So it is coming out to be equal to 80 by 3 milliampere. 80 by 3 milliampere. Sorry, not ampere. Sorry, not ampere. Not ampere, milliwatt. 80 by 3 milliwatt is the correct answer to this problem. Power developed across Zener diode. And yes, the correct answer becomes the option 3. Have a look at the options. 40 by 3, 20 by 3, 80 by 3, 160 by 3. So this one is wrong. If I try to calculate, okay, this one is also wrong and this one is also wrong. I hope this problem is clear to you. If you understood this problem, help me to solve this problem. Okay, solve this problem. It says that you need to find the current through the Zener diode when the load resistance is 1 kilo ohm. Okay, not 1 kilo ohm, load resistance. Okay, so this one is 2 kilo ohm, this one is 1 kilo ohm. So you need to find the current through the Zener diode for this circuit setup that has been shown to you. Anyone, put the answer in the comment box. I'm waiting for your answer. The problem is very similar, very similar to the last problem that we just did. Help me. In this problem, you just need to find the current through the Zener diode, not even the power. Just find me the current through the Zener diode. Anyone? Give me the current through the Zener diode. IZ is what I'm required to find. IZ. Let me name this as IZ. So IZ is what I'm trying to find. Anyone? Sir, is Zener diode work only in OARA? What is OARA? Point 2. Okay, let me solve this for you. First, let me find, okay, 15 volt is a total drop, 9 volt is drop across this. So there will be 6 volt drop across this, and there will be 9 volt drop across this, right? So I can write for 2 kilo ohm, I'm trying to solve. For 2 kilo ohm, I can write that 9 should be equal to I into R. R is what? 2 into 10 raised to the power 3. So I is coming out to be equal to 4.5 milliampere in parallel condition to resistance. Okay, I'm not getting your doubt, Rahul. What are you trying to ask? Okay, someone is commenting the answer, 1.5 milliampere. Okay, and what is the current through this RZ? For RZ, I'm trying to solve. The voltage drop is 6. Current, I need to find I, and resistance is 1 into 10 raised to the power 3. So I is coming out to be equal to 6 milliampere. I is 6 milliampere, and I prime, this is I prime, and this is I. So I is 6 milliampere, I prime is 4.5 milliampere. Obviously, the current through the Zener diode, it will be equal to 6 minus 4.5, that is equal to 1.5 milliampere. So that's how you deal with such kind of problem. This is the toughest level of problem that can be asked to you in the NEET examinations, and you just ace this problem, right? I hope this concept was clear to you. If this concept is clear to you, then let's move forward to the next problem. And the problem is based on, okay, it is a theoretical problem, a statement-based problem, again on the concept of semiconductors. It says that which of the following statements is correct? Which of the following statement is correct, not incorrect? You need to pick the correct one for PN junction under forward bias. Which bias? Forward bias. So you need to pick the correct statement for a PN junction under forward bias. Sir, is Zener diode working in parallel condition to resistance? No, I don't think it can work as a voltage stabilizer. Rahul, I'm not able to get your doubt. What are you trying to ask? But for the time being, let's move forward. We need to pick the correct statement for PN junction under the forward bias. And the first statement, the very first statement says that the forward current flowing in the circuit is of the order microampere. Okay. So the first statement says that whatever current is flowing in the forward biased PN junction, it is of the order microampere. Well, my knowledge says that for the reverse bias, the current is of the order microampere, and for the forward bias, the current is of the order milliampere. Because in the forward biasing, the current is due to majority charge carrier, and in the reverse biasing, the current is due to minority charge carrier. Okay, someone is commenting answer as option 3. Let us go through. So in the reverse bias PN junction, current is of the order microampere, and the forward bias, it is of the milliampere. So this one is incorrect. We need to pick the correct. Let's talk about the second option. The PN junction provides high resistance. See, in the case of forward biasing of PN junction, the depletion, the thickness of the depletion region reduces. And since the current is also due to the majority charge carrier, and the biasing of the PN junction is supporting that, so the resistance of the PN junction in forward biasing is low or very less. It is not. It doesn't provide very high resistance. So this one is also wrong. Let's go through the third. After the threshold voltage, the forward current increases significantly. Yes, this one is perfectly correct. If we try to draw the IV characteristic of the forward biasing, this is V and this is I. So it goes something like this. So this is the knee voltage or the threshold voltage, cut-in voltage, at which after this threshold voltage, the current in the forward biasing increases significantly. So this one is correct. Option 3 is correct. After the threshold voltage, the forward current increases significantly. So this one seems correct. Let's talk about the fourth one. The current is due to minority charge carrier. Obviously, this one is wrong. The current in the forward bias is due to majority charge carrier, not the minority charge carrier. So this one is also wrong. So the correct answer to this problem is option 3. I hope this problem was clear to you. Okay, if this problem is clear to you, then let's move forward to the next problem. And the next problem, right in front of you, problem 47 of the original paper, and it is based on the chapter of waves. It says that equation of a wave pulse is given as y equal to 4 sine 2t plus 0.5x. 2t plus 0.5x, where t is in second and x is in meter. Speed of the pulse. Speed of the pulse is what we are required to find. We need to find the speed of the pulse. The students, if this is the equation of the wave, transverse traveling wave, I can write the general equation as y is equal to a sine omega t plus kx, or I can write the equation as a sine omega t minus kx. This plus and minus, it will help you to determine the wave. Okay, someone is commenting the answer, but let me do the explanation part. If this plus sign and minus sign, it will help you to determine whether the wave is moving in the positive x direction or the negative x direction. So this one is moving in the negative x direction and this one is moving in the positive x direction. This is the basics of the wave. This omega t plus kx or omega t minus kx will help you to determine the direction of propagation of wave. Now, what is this omega? Omega is angular frequency. Angular frequency. Okay. And what is this k? K is wave number. I hope you are clear with both these terms, angular frequency and wave number. Okay. And how do we define omega? Omega is equal to 2 pi f. And how do we define wave number? K, it is equal to 2 pi by lambda. Now, from the basics of wave, from the very basic of waves, I know that velocity of wave, v is equal to f lambda. So from here, I can write that f is equal to omega by 2 pi. From here, I can write that lambda is equal to 2 pi by k. So v, it is equal to f lambda. What is f? F is omega by 2 pi. And in place of lambda, I can write 2 pi by k. 2 pi and 2 pi cancel. So velocity of wave, it is equal to omega by k. Omega by k is the velocity of wave, the correct expression. Okay, someone is telling me that it can be used directly. Yes, it can be used directly. I'm trying to explain to you the different terms related to the equation. So let's solve this. Velocity of wave, it is equal to omega by k. What is omega? Omega, this one is omega. So 2 by k. What is k? 0.5. Have a look at the units. Units, they must be in the SI unit. So x is in meter, t is in second. So the answer is coming out to be in meter per second. So 2 upon 1.5, that is equal to 4 meter per second. 4 meter per second is the correct answer. That's how you find the velocity of wave when you have been given the equation like this. So the correct answer is option 2, 4 meter per second. Okay, three students have given me the correct answer. That is 4 meter per second. Okay. Okay, dear students, I hope you are clear with this concept too. Let's move forward. Let's move forward to another problem. And there you go. Again, another problem from the chapter of waves, and it is more or less based on the topic of beats. It says that a tuning fork A produces 3 beats per second when sounded together with a tuning fork B of frequency 351 Hertz. So you have a tuning fork A which has a frequency FA, you have a tuning fork B which has a frequency FB, right? And the beat frequency when these two are sounded together is 3 beats per second, and you have been given that the tuning fork B has a frequency of 351 Hertz. The frequency of tuning fork B is 351 Hertz, and the beat frequency between A and B is 3 beats per second. So the possible frequencies of A is either 351 plus 3, that is equal to 354 hertz, or 351 minus 3, that is equal to 348 hertz. If I'm right, yes. So these two are the possible frequencies for the tuning fork A if it has to maintain the beat frequency of 3 beats per second. Now let's move to the other part of the problem. It says that if the fork A is waxed, now the fork A is waxed. What is the meaning of wax? Okay, someone is commenting the answer, 346. If it is waxed, please remember, if this is waxed, the frequency of tuning fork A is going to decrease. And after waxing, again when it is sounded together with B, then 5 beats per second are observed. Frequency of the fork A after waxing. We need to find the frequency of fork A after waxing. Please have a look at the problem. We need to find the frequency of the fork A after waxing. You don't need to find the original frequency. After waxing, you need to find. Okay. So let's solve the problem. So there are two possible frequencies. One is 354 hertz, one is 348 hertz. Now, if I consider this as my frequency 354 hertz, and after waxing it is going to decrease. So after waxing it is going to decrease. That means that it will be more close to 351. If 354 is decreasing, it will be more close to 351. So the difference won't be equal to 5 beat per second, right? So my guess is that 348 hertz should be the correct frequency of tuning fork A, because if you try to wax it, and if this reduces, the difference between 351 and something reduced can be equal to 5 beat per second, right? Okay. So from the analysis, we concluded that it is 348 hertz, right? 348 hertz is the frequency of tuning fork A. And now when it is sounded with B, after waxing, it is giving 5 beats per second. So it means that 351 minus 5, that is equal to 346 hertz. So the frequency of tuning fork A after waxing is 346 hertz, and before waxing was 348 hertz. You can be asked either of the frequencies, either the frequency after waxing or before waxing. So let me go through the option. Option 1 says that it is 346 hertz. Yes, 346 hertz is the correct answer. 340 hertz is the wrong answer. 342 hertz, again wrong answer. 354 hertz, again wrong answer. They are not even keeping the option as 348 hertz. So many students would have got tricked if I kept this option as one of the options. So obviously 348 hertz is the frequency of tuning fork A before waxing. So obviously I hope this concept is clear to you now. Yes, someone has commented the answer. Okay, I hope this concept is clear to you now. Let's move forward to another problem. And it says that, okay, a problem based on the simple harmonic motion. A problem based on the simple harmonic motion. Let me read the problem for you. It says that a particle executing simple harmonic motion along x-axis is given by the equation x equal to a sin omega t plus b, where a and b are positive constant, and amplitude of SHM is what you need to find. Electricity 1 is laughing. Okay. X is given to you as a sin omega t plus b. This is the equation of the SHM, and you need to find the amplitude of the SHM. Okay. If I rearrange this equation, I can write that x minus b, it is equal to a sin omega t. X minus b is equal to a sin omega t. So what is the problem in this equation? Many people must be confused that whether this b will be a part of amplitude or not. That is the most basic confusion that you students get in these kind of problem, that whether this b will be part of amplitude or not. Had the equation been like this, x naught is equal to a sin omega t, every one of you must have commented the answer as a. Every one of you must have commented the answer as a had this been the equation, but obviously this is not the equation. Equation is x minus b is equal to a sin omega t. The only difference in this equation and this equation is that for this equation the mean position is x equal to 0, And for this equation, the mean position is x equal to b. That's it. That is the basic difference between both these equations. One of the equation, the mean position is x equal to 0. In this equation, the mean position is x equal to b. Now, amplitude is defined as the distance the object covers from mean position to one of the extreme. So, mean position to one of the extreme, this will give you the amplitude. Now, the mean position is b and the distance covered will be a. So, the amplitude of this equation will be a only. Clash of Clans is commenting B. No, B is the mean position. The mean position is shifted over here. The mean position is not at x equal to 0, but it is at x equal to B. So, yes, the amplitude is going to be A only. Amplitude is going to be A only. The correct answer is option A, that is A. Not B, not A plus B, not B minus A. Not a mod of B minus A. I hope this part is clear to you. Clash of Clans B, not B. B is the mean position. Amplitude will remain A. Okay. Can someone give me the time period of this? Someone give me the time period for this equation, x equal to a sin omega t plus b. It's Mr. Beast. Hello, sir. Hello. Someone give me the time period for this equation. Anyone can put the time period in this equation. And let me move forward. Okay, problem 39 of the original paper, and it says that which of the following phenomena are not shown by the sound waves? Which of the following phenomena are not shown by the sound waves, and the phenomena are right in front of you. First one is interference, second one is beats, third one is diffraction, fourth one is polarization. T is equal to 2 pi by omega. Yes, very well, very well. Now see that sound waves, the very basic nature of sound waves is that they are longitudinal. Sound waves, they are longitudinal. So this is the nature of the sound waves, they are longitudinal. And we all know when we went through the chapter of waves, we know that interference is shown both by both transverse waves as well as the longitudinal waves. Beats, obviously, two sound waves of very close frequencies, they can give you the phenomena of beat. So this phenomena can be shown by the interference, can be shown by the sound wave. So this cannot be our answer. Beats, it cannot be our answer. Diffraction. Okay. Diffraction is also not our answer because diffraction is also shown by the sound waves. What about the polarization? What about the polarization? See, the very basic nature of sound waves is that they are longitudinal in nature. And if a wave is longitudinal in nature, there is no vibration perpendicular. There is no vibration in the direction perpendicular to the propagation. If this is the direction of propagation, there will be no vibration in the direction perpendicular to the propagation. And if there is no vibration in the direction perpendicular to the propagation, then there is no use of polarization because this is already polarized. These vibrations will be absorbed by the polarizer. So these vibrations don't exist for the sound waves because obviously they are longitudinal in nature. So no need for polarization. So they won't undergo polarization. So this should be the correct answer. And among all these options, the phenomena which is not shown will be polarization. Rahul, only transverse. Yes, very well. The polarization is only shown by the transverse waves, not the longitudinal waves. So the correct answer is option 4. Correct answer becomes the option 4, that is polarization, right? I hope this part was clear to you. Okay, let's move forward. Okay, the problem based on the chapter of, can you please brief polarization once? Okay, I'll discuss the polarization, but let me first go through this problem. It says that the magnetic intensity required to demagnetize the material is. So we need to understand what do we call the magnetic intensity required to demagnetize the material. So this problem is based on the chapter of magnetism and matter, and my knowledge says that it is based on the concept of hysteresis curve. Okay, let me draw the hysteresis curve for you. See, this is the hysteresis curve. I'll draw. Here is your magnetic intensity, and here is your intensity of magnetization. I hope you are clear with both these terms, magnetic field intensity and intensity of magnetization, right? Now what happens is that as I apply the field, external field, the domains start getting aligned, and they will be aligned, and they will reach the saturation. So this is the saturation point. I'm trying to draw the hysteresis curve. So this is the saturation point. At this point, all the domains are aligned. We say that the saturation condition has come, right? So as you increase the field, there comes a point where you get the saturation. Now from this point, if you try to decrease the field, if you try to decrease the magnetic field intensity, the graph will be something like this. So I have decreased. Now have a look at this point A. Even if the external field is, vanished, or it has become zero, some intensity of magnetization is still left in the material, and this is known as retentivity. When H is equal to 0, some part of I is still there in the material. This is called the retentivity. Now, if you apply the field in the negative direction, the I will further reduce to 0. So, the strength of the field that is required, the magnetic intensity that is required to make I, or intensity of magnetization, 0 is known as coercivity. And if you extend the field in the negative direction, if you increase the field in this direction, again the domains will be aligned till the saturation point, right? And if you try to decrease the field, again the same behavior, you will get the retentivity. The magnetic intensity is dropped to 0, but again this much intensity of magnetization is with the material. And if you try to increase the field in this direction only, again at this point I become 0. Then if you increase the field further, it will again become saturated. It's not a very good curve, but something like this. So this part shows you the coercivity, and this part shows you the retentivity, right? Now have a look at the problem. It says that the magnetic intensity required to demagnetize the material is. So this part he is asking the magnetic intensity required to demagnetize the material. That means at what value of H I becomes 0. This is known as coercivity. So not retentivity, not energy loss, not hysteresis. Coercivity is the correct answer to this problem. I hope you are clear with this. Coercivity is the correct answer to this problem, right? So dear students, and I'll end the lecture with this problem only. I hope I covered all the concepts thoroughly and you enjoyed this session. And please subscribe to our channel and keep tuned for more such videos, informative videos for your NEET examinations, and all the very best for your NEET examination.